Here are solutions to homework set number 4 for ECE 376. What we're going to get in this homework set is add an LCD display, add a keypad programmed in C, and we're going to play a game of Mastermind. I'll start the game with a random number, and then using keypad, input a guess, like is the code 1234. Try it, and we got 3 points. So 3 of the digits in the code are in this sequence, none are in the right spot. Is it 0, 1, 2, 3? 0, 1, 2, 3. 2 digits of the code are in the guess, none are in the right spot. That's a game of Mastermind. That's what we want to get at the end of this homework set. Now, in the previous homework sets, we looked at assembler programming. We're going to switch over to C coding right now. In C, we have things like multiply, divide, loops, subroutines, stuff like that. Makes coding a whole lot easier. In this homework set, we're going to look at using C code with the LCD display and a keypad to build a Mastermind game. Starting out, let's just look at how long it takes C code to execute. So here's your C program. How long does it take to count an 8-bit number? On assembly, I'd expect that'd be like 1 clock. In C, that's actually kind of hard to calculate because one line of C can compile into many lines of assembly. One way to do that is try it. So here, I've got MPLAB. Here's my program. I want to count mod 256. Want to get to 0, send that count to port C, and try it. So let's do project, build. Go over to the super amazing thing for downloading the code. Hit reset and program. Okay, so trying that. Here's the code downloaded. If I check the pins, this is RC0. 1304 Hertz. What that means is the number of clocks between interrupts is 38,000. It toggles every 256 loops, so divide by 256, 14.992. Takes about 15 clocks to count mod 256. In assembly, I can do that in 1 clock. C is not quite as efficient as assembly, 16 clocks. Okay, let's make a little bit of a change. Let's go back to this code. And instead of counting mod 256, let's count mod 255. When I do that, the code is suddenly bigger. When I download it, go over here, download. The frequency is a lot lower. Kind of hard to read with the Piano Tuner app. Let's see. It's actually 41 Hertz. What that means is it's now 477 clocks per loop. So counting mod 255 is 477 clocks. Counting mod 256 is 16 clocks. The reason being is in binary, powers of 2 are easy. Things that aren't powers of 2 are really hard. It's a different algorithm, takes more clocks. How long does an integer multiply take? Well, let's try it. Let's multiply A times B, toggle RC0 every 256th loop, and I wind up with 42 Hertz. That means it takes about 461 clocks to multiply two 16-bit numbers. How about a floating point multiply? Floating point multiply takes 228 clocks. And kind of one trick you can do, instead of doing 256, this drops the frequency, make that a power 2, like 128, 64, 32. That changes this number. For the Piano Tuner app, it works best if I'm typically above 200 Hertz, less than about 2000 Hertz. If you have a frequency counter, I can count 85 Hertz square wave just fine. So that was problem number 1. Okay, the next part is use the keypad, use the LCD display to create a game of Mastermind. So here, I start the game by hitting RB1. That's because my RB0 button is starting to wear out. That generates a 4-digit code. Each number is between 0 and 6. I then take a guess. Like, let's guess, is the number 1, 2, 3, 4. I input that number with the keypad and then try it. It then checks. Takes the code, each digit. If this number appears in the code, I get 1 point. If it appears in the right space, I get 10 points. So I got 1 point, so I know there is only one digit in the code. That's 1, 2, 3, or 4. So 0, 5, and 6 must have 3 numbers. So let's try 1. Let's not do that. Let's clear that out. 0, 5, 6, 1. Is that the code? And 2 digits are correct. None are in the right spot. So that's kind of how the game of Mastermind goes. I want to keep on going until I can figure out what the code is. How do I write that program? So rather than write the whole code all at once, I'm going to go in baby steps. Now the first thing I want is just get the LCD display to turn on. So I'll initialize the display, send my welcome message to the screen. Here's the welcome message. Just code and guess. If I try it, that's what shows up. Code and guess. LCD is working. Okay, so far so good. Okay, now that the display works, let's generate the random code. I'll wait until I hit the button, then release it, counting really fast. Once I release it, take that number mod 6, generate a 4-digit, base 6, and display it. So here's what that looks like. I press, release, there's my code, 51111. Try it again, new code, new code. After a while, I'm convinced that's a random 4-digit number. Each number is between 0 and 5. Okay, that works. Let's go on. Let us input the keypad. To read the keypad code, I'll include the keypad routines. This is the get key, read key, go into your main loop right here. I'll read the keypad. If it's number 0 through 9, interpret that as the number times 10 plus the number. And this is the delete key. See if I can input numbers. So build it, download it, see if it works. So generate a code. There's my code. Let's type in the number 1, 2, 3, 4. And try it. Okay. 3, 3, oops, clear. 3, 3, 5, 4. Okay, so I can input the numbers. That looks good. Once I can input the numbers, then let's check my score. I'll grab a subroutine called compute score. So this is the tricky one. I've got the code, I've got my guess. I want to go digit by digit. What I'm going to do is pull out each digit out of code. That's the zeros, ones, tens, hundreds, thousands digit. Likewise for the guess, and then check. For each digit in the code, I start with 0 points. If that digit matches up in my guess, I get 1 point. If that digit matches up in the right spot, I get 10 points. Increase the score, and then display it. So let's try that. I'm going to go to compile, build, and here's what it looks like. Code is still downloading. Fairly long program. So I'll start out. There's the code, 4053. Let's guess 1, 2, 3, 4. What it should get is the 4 matches up in the wrong spot. That's 1 point. The 0 does not appear. 5 doesn't appear. 3 appears in the wrong spot. That should be 2 points. Try it. I get first guess, 2 points. Let's try the number 4055. Try that. That should be 3 points. 30, 30 points. And it is. Let's try 5555. That should be 10 points. The 1 digit's correct in the right spot. That looks good. Let's try 4053. 40 points. All right, that all looks good. So finally, let's not display the code when you start the game, because that makes it too easy. To Project, Build, Reset, Download. I'm now playing the game of Mastermind. Generate the code, and let's take my guess. 1, 2, 3, 4. Try it. 1, 2, 3, 4 is 2, 2. So all 4 digits in the code are in the sequence, 2 in the right spot. So let's try 2244. Clear that out. 2244. Try it. 2244, and I just got lucky. I got it in 2 guesses. That's the game of Mastermind. What to note about this homework set is with a keypad, I can input numbers. LCD display, I can display information. LCD is really useful for debugging your code. Third thing to note, this is actually a fairly complicated program. When I'm done, this is 6,452 bytes, 3,200 lines of assembly. I would not want to write this in assembly. And C is not too bad. The other thing to note is I did top-down programming. I start with just the basic structure, get it to work, get the display to work, and start adding features one at a time. That's one way to write a program that's fairly complicated and getting an answer in finite time. If I try to do this all at once, I'd get really frustrated. If I go step by step, it ain't too bad. And that is homework set number 4 for ECE 376.